Black holes, the weirdest thing in the universe. You've probably seen them in movies, those cosmic vacuum cleaners sucking up everything in their path. But what they don't show is just how dense a black hole really is. Imagine squishing the Earth down until it's the size of a marble. Yeah, it's that dense. Or picture this, a black hole with the mass of the Sun. It will be so small you could fit more than 30 of them in London. That's the kind of density we're dealing with. This insane density gives black holes their unbelievably strong gravity. No matter how fast you try to escape, once you're too close, it's game over. Even light cannot get away. Scientists are still scratching their heads trying to figure out the ultimate question. What is inside a black hole? Well, today's the day we find out. Brace yourselves because we're going on a mission to dive into a black hole. Before we start, we've got to understand the force that keeps everything moving in space: gravity. You've heard the basics. Gravity is the pull between objects. But the real question is, how do things pull on each other when they are so far apart? Nobody really questioned it until Albert Einstein came along, poking holes in our understanding. He figured out that gravity actually warps the space around it. Put simply, imagine the whole universe as a giant stretched-out sheet. If you put the rock in the middle, everything else on the sheet starts rolling toward it. The heavier the rock, the stronger the pull. Now, a black hole is not just a heavy rock. It's so heavy, it rips a hole right through the sheet. Anything that gets too close falls in and can climb back out. Okay, we now understand how black hole works in simple terms. But we need to know how dangerous they are. Here's the plot twist. Black holes are not the greedy monsters movies make them out to be. Most black holes in the universe are chill. They have already, quote-unquote, eaten their fill and are just hanging out. If you replace our sun with a black hole of the same mass, guess what? The planets would keep orbiting like nothing happened. Well, except we would freeze to death. For our mission, we'll find an active black hole, one that is still eating. You can spot them because they shine with a crazy light show. All set? Let's imagine we found a black hole as massive as the sun. Time to answer the big question. What happens if we go in? Our rocket safely approaches the black hole. If you step outside to float around, here's something wild. You will see the back of your own head. Seriously, the black hole's gravity is so strong, it bends light back towards you. That's why black holes have those glowing rings around them. We head closer to the edge of the black hole. From an outside observer's perspective, something weird happens. They will see us slowing down. The closer we get, the slower we seem to move, until eventually, it looks like we just freeze. Our rocket will start going red, dimming, and then, poof, vanish. Inside the rocket though, we'll feel fine at first. But as we move deeper, gravity starts pulling harder on the parts of us that are closer to the black hole. Imagine being stretched like spaghetti. Yep, this is what scientists literally call spaghettification. Your body gets stretched into a super thin strand of particles. But what if we aim for a bigger black hole, like the supermassive one at the center of our galaxy? Here, you could cross the edge, the event horizon, without turning into space spaghetti. But after that, it's like being caught in a cosmic whirlpool. No matter how hard you swim, you're going down. Eventually, you're surrounded by darkness. The entire universe shrinks into a tiny dot, fading away until there's nothing. At the center, you'll reach the singularity, a point where all the black hole's mass is squished into infinite density. And within hours, every particle of you would merge into the black hole itself. Okay, all of that might sound totally crazy, but even that is just the beginning. Everything we just explained applies if we assume black holes are stationary. But in reality, almost all black holes in the universe spin. That's right, almost all black holes are actually spinning black holes. This makes their gravitational pull even stronger. Some spin so fast they're nearly at the speed of light. Spinning black holes have an extra weird zone around them. If you enter it, you'll get dragged along with their spin. Escaping it will take insane energy, even though technically it's possible. On top of that, weirdly enough, black holes can collide. When they do, they merge into an even bigger black hole. Scientists have made the simulation before. And they even simulated the sound of these collisions. And guess what? The supermassive black hole at the center of our galaxy is on a collision course with the one in our neighboring galaxy. But we can relax, that's a few billion years away. The even stranger part is that we still don't fully understand how black holes even come into existence. The process of how black holes form, especially the supermassive ones, is still shrouded in mystery. We only have one clear explanation so far. Black holes are born from the death of massive stars in an explosion called a supernova. Only stars that are at least 20 times heavier than the Sun end their life this way, like this star for example. And just like stars, black holes come in different sizes. Let's take a look at some of them. Okay, here is the Sun. Now, here is the black hole at the center of our galaxy. Next, this is the black hole in our neighboring galaxy. This one is the first black hole we ever took a picture of. And finally, this is the biggest black hole scientists have ever found. The size of these supermassive black holes is mind-boggling. Based on the age of our universe, they should not even exist yet. There are a few theories trying to explain how these supermassive black holes came to be. Maybe they form from massive gas clouds collapsing under their own gravity. Or perhaps, not long after the Big Bang, violent seeds of black holes emerged and consumed everything nearby to grow larger. These seeds might have been formed by collisions between the universe's first stars or by those stars burning out quickly and collapsing. Another theory suggests that before stars even existed, the universe was still unstable, creating black holes everywhere. So, the birth of black holes, especially the supermassive ones, remains one of the universe's biggest mysteries. But what about how they die? At first, these had scientists scratching their heads. But then, we found new clues thanks to quantum physics. It turns out, black holes emit a kind of radiation throughout their lifetime. Slowly but surely, they shrink and eventually explode in a dramatic finale. But this process takes an unimaginably long time. For us humans, with our fleeting lifespans and short-lived civilizations, black holes might as well be eternal. And then there's another problem. Here's the thing. Everything that falls into a black hole becomes part of it and eventually evaporates. This means all the information about what went into the black hole is completely erased from the universe. Gone. And that conflicts with the laws of physics, making it one of the hottest debates and research topics among scientists today. So, does that mean a black hole can be destroyed? What if we use an ultra-powerful nuclear bomb? Or smash it into another black hole? Turns out, in both scenarios, it doesn't get destroyed, it just grows bigger. But maybe there's another way. Introduce it to its twin. Meet the white hole. If black holes suck in everything that comes close, white holes are the opposite. They spit out matter and energy from within. There's a possibility that if the two met, they would cancel each other out. Unfortunately, white holes are purely theoretical at this point, and many scientists doubt their existence. Kind of like how black holes were doubted in the past. Maybe one day, only one of you that are staying in school right now who will study and discover white holes in the future. This is the first ever photo of a black hole. It was the result of collaboration between hundreds of scientists and many telescopes spread across continents. It has taken centuries for us to truly see and understand the most mysterious object in the universe. The discovery of black holes didn't start by looking up at the sky, but by looking down onto sheets of paper filled with mathematical equations. It all began with the curiosity of a genius about gravity. He discovered evidence of an object with a gravitational pull so strong that nothing, not even light, could escape it. At first, even he was skeptical, until one day, he received a letter from another scientist, providing mathematical proof that black holes could really exist. From that moment, humanity began looking to the skies for evidence of their existence. And although they are invisible, we can observe black holes by studying their impact on the universe around them. Black holes are truly one of the strangest marvels of outer space ever imagined by humankind.
It is said that fact is sometimes stranger than fiction, but nowhere is that more true than in the case of black holes. Black holes are stranger than anything dreamed up by science fiction writers, but they are firmly matters of science fact.